Alright, so now a couple of application problems. First thing you need to do is define your variables. So the way you know how to do that is you look for what the question is asking. It says how many of each ticket were sold. So X is going to equal number of, now what types of tickets were there? Student tickets, and then there were general admission tickets. So you define those two variables, and then the first step in setting up your actual equations is to look for totals. So we have a total of number of tickets and a total of money. So what we're going to do is, how do I get those total number of tickets? Well, since X stands for number of tickets, number of student tickets plus Y stands for general admission, so number of general admission tickets should give you the total number of tickets. And then if we were to take the price for each, so if we took the price for the student tickets times the number of them, that gives us some dollar amount that's for all the money for the student tickets, plus the price of the general admission tickets times how many we sell. Remember that Y stands for general admission tickets. So if we multiply that number times its price, then that will give us a dollar amount for the total money we make off of general admission tickets. Add those two together, and we get the total dollar amount. Next, we just solve with the elimination method. Alright, so this one's a bit more complicated. It's got a little bit more going on. So what we want to do is take two batches of chemicals, one stronger, so we'll have this be the 40%, and this will be the 60%, and we want to combine them so that we get some medium-ish 48%. But we have to combine them in the right amounts. So do we need a lot of the weak and a little bit of the strong, or a lot of the strong and a little bit of the weak? So what we're going to do is actually set up a system of equations to solve this. Now, the first step, again, was to define our variables. So since it says how much of each solution, X should be the amount of the weak, and Y should be the amount, and we're in milliliters here, of the stronger solution. Since we need 200 milliliters, we should combine the amount of weak plus the amount of strong, and that should equal 200 milliliters. So where do we get our second equation? Well, of the 200 milliliters, 48% of that, so 200 liters times 0.48, is the pure chemical. So if we take the amount of the weak and multiply that by 40%, that gives us the amount of pure chemical that we're getting from that one, plus 60% times the strong, because the amount of the strong, which is this, times the percent concentration gives us the total amount of the pure chemical that we're getting. So if we get the amount of chemical from the weak and the amount of chemical from the strong, that gives us the total amount of pure chemical that we're looking for. For the sake of brevity, I'm not going to actually solve this equation, but you would just use the elimination method. You would simplify this to 96, and then you could multiply the whole thing by 100 and get 4x plus 6, or whole thing by 10 rather, get 6y equals 960. So then we no longer need that equation, and then with these two systems of equations, you would just multiply the top equation by -4, -6, and then solve. Of course, you should get positive numbers, because negative numbers wouldn't make sense in this application. And yes, of course, you're going to have homework based upon this video. This stuff will be done in class.